This invention relates to a hydraulic tension tie for construction works to protect them against earthquake and hurricane damage. This is achieved by a continuous pre-stressing, pulling that is, of both the building structure towards the ground and the ground towards the structure, making these two components one body, like a sandwich. The mechanism comprises of two main components, namely the pressure chamber, the upper part, and the anchor, the lower part. These are connected by a steel cable which passes freely through the center of the structure's vertical support and down through a drill hole beneath the ground. The top end of the steel cable is tied to a hydraulic pulling mechanism which exerts a continuous upward force. The lower end is tied to an anchorage mechanism that is driven into the walls of a drill hole, preventing it from being pulled upwards. The pulling force applied to the steel cable by means of the hydraulic mechanism, in conjunction with the resistance created by the anchor, produce the desired compression in the structure. This combination of opposing forces exhibits the following behavior during an earthquake. The rest of the building oscillates around the lift shaft, which remains immobile. The building makes contact with the mechanism via rubber blocks at various points along the gap between the lift shaft and the rest of the building. These act to absorb the stress put upon the building, preventing the vertical axis from exceeding its fracture point and collapsing. The structure does not assume an S-shape as a result of the inertia of the floor face. In this way, the building maintains its structural integrity.